Hey guys, so this video is about absolute value inequalities, and they are a little bit tricky. So there's this kind of template up here for what we do with the less thans and the greater thans, and understanding these two things is kind of the key to the whole section. So I'm going to go through a couple of fairly simple examples and just try to break down why a less than does this thing it does and why a greater than does this thing it does. And I accidentally had a minus there, so that's just a little, I scratched it out, it's a little blob, but that should be a regular positive C. So let me do this greater than 1 first. If we think about the absolute value of x is greater than 5, you can kind of think, so if it was equals, if I put in, like the last section, equations, if I put in absolute value of x equals 5, it would be 5 or negative 5, right? Because that's absolute value of 5 is 5, absolute value of negative 5 is 5. So that's going to be our boundaries, is on the 5s. So I'm just going to throw negative 5 here, positive 5 here. And if you think about, if I put numbers like 6, 7, 8, 9, absolute value of 6 is greater than 5, and so forth, 7 would be greater than 5. So all this stuff out here is going to work. If I try the absolute value of 3, something in the middle, 3 is not going to be greater than 5, that doesn't work. And that's going to happen all the way down to negative 5, right? Even if I put negative 4, absolute value of negative 4 is 4, not bigger than 5. But when I get out here to negative 6, then I'd have like the absolute value of negative 6 is greater than 5. Absolute value of 6 is 6. And so then that becomes true again. So that means this piece out here works. And so that's what we're seeing with this graph. In this case, there's no equals, so I'd be using open dots on my endpoints. But so a greater than, what this is really saying is the absolute value of x has to stay more than 5 units from the origin, is what we're seeing. So this has to be greater than 5, so we're out past 5 either way. I kind of joke that this one looks a little bit like a restraining order, that you can't get within so many units of the origin in this case. A less than, this one actually ends up kind of looking like a house arrest. If I think kind of through the same way, if I did, the 5s are going to be my boundaries. Oops, I wrote 6 because I was thinking 6. So if I put negative 6 in here, absolute value of negative 6 is 6, not less than 5, didn't work. But if I put negative 4, that would work. 0 would work, 4 would work. Anything right up to 5 would work. But then if I come out here to 6, again, then 6 is not bigger than 5. So what we're getting is the exact opposite of this graph. And this time, again, no equals, so open dots. And so the less thans are saying it has to stay within 5 units of the origin. So this one has to stay greater than, more than 5 units out. This one can only go 5 units out. So this one's, like I said, kind of like a restraining order. And this one is kind of like being on house arrest. You have to stay within 5 units of right there. So that's kind of the basics of how these things work. So every lesson we're going to set up as this kind of continued inequality between the negatives. Every greater than, we're going to set up less than the negative or greater than the positive. And if you look at the arrows, they go the same way as the graph, right? So that's kind of a nice way to remember that. Less than the negative, greater than the positive. So I forgot to do interval notation on these, so let me show that. This is going to go from negative infinity up to negative 5, and then in parentheses, because the open dot. Union, remember that's how we jump over the gap like that. And then 5 to infinity. And then this one will just be from negative 5 to positive 5. Okay, so for number 3, we got the greater than. And so the greater than is the kind with the or, so we're going to have a graph that's going to do this. And so remember that this sets up x minus 2, it's just the stuff inside is going to be less than the negative. That's going to be our piece going this way. Or x minus 2 is going to be greater than the positive. That's going to be our piece going that way. And so then we just plus 2, plus 2. And we get x, that cancels, is less than negative 3. X is greater than 7. And then for graphing, we'll just come to negative 3, open dot. X is less than, so we're going this way. We'll call that 7. X is greater than, and we're going that way. So every greater than is going to have that or, and set up as 2 branches, kind of like this one. So here we got a less than. And this one, just to kind of show the difference on those 2's, if I go, this one I have to go plus 2 first, because we want to isolate the absolute value. So then this becomes absolute value of x is less than 7. And then from there, it's a less than, so that means it's going to set up in between the 7s. So I'm going to have negative 7 is less than x is less than 7. So that would be my inequality notation. And then as an interval notation, it would be negative 7 to 7. I keep forgetting to write those down. So this would be negative infinity to 3 union 7 to infinity. In the graph here, we'll just call those the 7s. And it looked just like that. Okay, so this time we get a fraction greater than, so we're going to set up the 2 branches. So 8x plus 5 is either less than or equal to negative 2/3, or 8x plus 5 is greater than or equal to positive 2/3. And I'm not loving the 3, so I think I will clear the fraction. So I'm just going to multiply both sides by 3. So 3 times 8 will get us to 24x plus 15 are less than equal to, 3's cancel there, and I just have negative 2. And then I'll bring my 15 over. And that's going to be 24x less than or equal to negative 17. Divide both sides by 24. And x is less than or equal to negative 17/24. Not a very nice answer, but what we got. And I'll do the same on this side. It's 15, cancel. So that side comes up positive 2. And then we'll just do the same stuff, bring the 15 and divide the 24. And we'll just divide. And those cancel. So those are our 2 not very nice answers, but they are what they are. So this would be negative 17 over 24. This would be negative 13 over 24. And that our graph would look like that. And then our interval notation is just kind of what you would think. Let's see, open, oh, whoops, so this should be closed. And then that should be bracket, union, bracket to the negative 13 and 24. Okay, so in the lecture section, these next 4 would be to you guys. This one's a little sneaky because that negative x, let's take a look at that. We have 6 minus x, so this is a greater than, so it's going to be less than the negative, or 6 minus x is greater than or equal to the positive. So I'll move the 6 over. So that cancels, and I have negative x is less than or equal to negative 11. And I have to multiply both sides by negative 1. But that's right here, notice there's an inequality, so that means I have to reverse my inequality, and that's an easy thing to miss. That cancels, so I have negative x is greater than or equal to negative 1. Same thing, I'm doing the bit with the negative 1. So that's going to make this x less than or equal to 1. So go here's 1, make that one 11, and should look something like that. And then we're going from negative infinity up to 1, and then from 11 out to infinity. We got a less than this time, so we're going to do the in between. So we'd have negative 4. It's going to be less than the stuff inside. Is going to be less than 4. And then I can add this 1 everywhere. And I got negative 3 is less than 3x, those cancel, is less than 5. And then just divide this 3 out. So I'd have negative 1 is less than x is less than 5/3. So our graph would just be like this. And then our interval notation from negative 1 up to 5/3. Okay, so we got a greater than, so we're going to set it up as an or. So it's going to be less than or equal to -2, or same stuff, oops, with an x, greater than or equal to +2. And this one, rather than clear the fractions immediately, I think it's easier if I just move this. So I have -4/3 x less than or equal to, that'll be a -1, and -4/3 x. Those cancel, so greater than or equal to 3. And then I can just use reciprocals, so that's why I didn't clear it this time. So I'll do a -3/4 on both sides. So I'll cancel all this. So all that's gone, and I have x, and then I did just multiply by a negative, so I gotta be careful and remember to switch that. So x is gonna be greater than 3/4. All that cancels. Again, I did the negative, so I gotta switch that. It'll be -9/4. So x is less than 9/4, or -9/4, and x is greater than 3/4. So these are equals, we got solid dots. And then our interval would be -infinity to -9/4, union 3/4 to infinity. Last one. So this is a less than, and it has all kinds of fractions, but it's going to be okay. So what I will do is I'm going to do -1/2. That's going to be less than all that stuff. Less than 1/2. But then I can clear the fractions, and then that will make this much better. So I'm just going to multiply everything by 6 because it's the LCD. -3, so that's going to be less than. So right here, this is a little sneaky. So 3 goes into 6 twice, but then that 2 is still going to have to multiply this stuff. So I'm going to write it as 2 5x minus 6, and then less than here, this would go in 3. So I'm canceling the 3 into the 6, making the 2, and then it's going to multiply that. So I'll go ahead and distribute now. And I can add that 12. So down 12, or up 12, down 3, so that'd be 9 is less than 10x is less than 15. And then I can just divide out that 10 right there. And that's just about it, except we should reduce. So it'll be 9/10 is less than x. And then 15/10 is 3/2, right? When I knock the 5s out. So 5 times 3, 5 times 2, I'm doing that. So then that comes up here. So it's that kind of graph. And then our interval notation is just kind of what you would think. Cool. And that concludes absolute value inequalities.